In 2024, the Nobel Prize in Chemistry was awarded to three pioneers, David Baker, Demis Hassabis, and John Jumper, whose groundbreaking work cracked the code of protein folding, a problem that puzzled scientists for over half a century. Protein folding is the process by which proteins end up having a specific shape based on what they do. Take hemoglobin, for example. It's a protein that folds into a precise structure, enabling it to transport oxygen through your blood. There are more than 1,000 ways in which proteins can fold depending on the purpose. Thousands of proteins exist because the 20 different amino acids can be combined in many sequences to create a vast array of unique proteins, much like words formed from combinations of letters. Once in a while, however, the proteins don't fold exactly as required. And this becomes the beginning of diseases like cancer and Alzheimer's. In cancer, malfunctioning proteins fail to regulate cell growth, and this leads to formation of tumors that become a cancer disease. If scientists could figure out at what stage a mistake occurs during protein folding, they can be able to curb the cancer and other related diseases. Traditional methods like X-ray crystallography and cryo-electron microscopy took years to reveal a single protein structure. In 1994, the first CASP, Critical Assessment of Protein Structure Prediction, competition was held to benchmark computational models. The results were, however, underwhelming. Most predictions often missed the mark, highlighting just how difficult deciphering protein structures was. To solve this problem, David Baker, a young researcher at the University of Washington, created a software platform called Rosetta, hoping to design proteins with specific functions. But Rosetta's early version struggled. In one test, the program generated protein shapes that were so inaccurate they couldn't even bind to their intended targets. Frustrated but determined, Baker pushed on, refining his algorithms year after year. And in 2006, Seattle, with a team of researchers, he unveiled the first successful version of Rosetta, a tool that could not only predict protein structures but could also design new ones from scratch. To measure the success of Baker's software, companies like Moderna and Amgen quickly adopted Rosetta's technology, using it to develop life-saving vaccines and therapies. However, one challenge arose: complex protein structures like the ones involved in cancer cells often required significant computational power that even Rosetta couldn't crack all the puzzles. Therefore, the field needed a new approach, something that will be faster, scalable, and capable of tackling proteins that had eluded even the best human-designed model. And that is where Demis Hassabis and John Jumper began a bold new endeavor. In 2016 in London at Google DeepMind, their goal wasn't to design proteins. They chose to focus on predicting how any given protein would fold using artificial intelligence. 2 years later in 2018, their first prototype, AlphaFold, debuted at the CASP competition. And though it was impressive, it still wasn't a silver bullet. Jumper recalls how one protein, designed to showcase AlphaFold's capabilities, missed its predicted shape by critical margins, leaving the team both frustrated yet motivated. Over the next 2 years, they refined their algorithms. And finally, in 2020, AlphaFold 2 debuted at CASP 14, accurately predicting the structure of a protein called T1059 within minutes. The breakthrough was undeniable. Leading biologists at the event called it the eureka moment of computational biology. AlphaFold 2's success wasn't just about speed. It transformed protein folding from a painstaking years-long process into something achievable in hours, unlocking possibilities across drug development, synthetic biology, and more. Baker, Hassabis, and Jumper had their paths converged in 2024 when they were jointly awarded the Nobel Prize in Chemistry. Their work exemplified the synergy between computational science, chemistry, and biology, proving that seemingly insurmountable problems could be solved through collaboration and innovation. With their combined achievements, scientists understood proteins like p53, which are responsible for controlling cell growth. When these proteins malfunction, cells grow uncontrollably, forming tumors. Baker's designed proteins are now being used to target and repair these faulty mechanisms, offering hope for more effective cancer treatments. In Alzheimer's, the buildup of misfolded proteins like beta amyloid plaques destroys brain cells, leading to memory loss and cognitive decline. With AlphaFold 2, researchers can now model these structures accurately, paving the way for therapies that prevent or even reverse damage. AlphaFold is also being used in agriculture to create more resilient crops and in renewable energy to design enzymes that produce biofuels. The 2024 Nobel laureates in chemistry have redefined what's possible. They've shown that with persistence, creativity, and teamwork, even the toughest scientific challenges can be overcome. So every science enthusiast watching this, whether in school, work, or wherever the place, just know science needs dreamers like you. Maybe your passion lies in chemistry, AI, medicine, or any other field of interest. You have the power to make a difference. Hit the subscribe button, give this video a like, and share it with someone who loves science. And tell us in the comments, what challenge would you love to solve? Let's build a community of innovators ready to change the world. Until next time, stay curious.